Hello everybody, this is Dr. Reyes-Fournier, and I decided to do a quick refresher for you to discuss variables. I noticed that basically in the class we don't really go through that because you should know this already, because you've discussed this in Intro to Psych, in your Intro to Experimental Methods. Variables have been discussed quite a lot with you already, but not the same way that we're doing now. So let's talk about variables. What is a variable? A variable is an object, event, idea, feeling, time period, or any other type of category you are trying to measure. It could be something as simple as, weight, or something as complex as, marital satisfaction. Okay, those are all types of variables. So an independent variable is exactly what it sounds like. An independent variable stands alone and it isn't changed by other variables that you're trying to measure. So independent variables are things that are pretty much static, like your age, your gender. And I know that one just sounds funny, being that, your gender might be different, but it is something that it is static, okay, at the time that you're doing the experiment. Educational level is another kind of independent variable. It's like if I test you today, you would be a freshman, sophomore, junior, senior in college. So that's a static variable, which makes it an independent variable. A dependent variable is exactly what it sounds like as well. It's something that depends on something else. So if you think about the independent variables I just mentioned, like age, things like your results on a test depend on your age. So, for example, you take a test today at the age of 25, and compare yourself to take that test when you were 6 years old. Obviously, there's going to be a difference there. And what did I change? I changed the age, which means I'm manipulating the age, which is the independent variable. All right, so I'm going to give you an example of how this is done. Now, this is a really bad slide because you can't see this that well. Independent variables are the things that you manipulate. So that would be the cause of whatever happens to the dependent variable. So for example, in the example that I'm going to give you, we're going to talk about specifically caffeine intake. And it's kind of cut off on the bottom, and I'm sorry about that. But in this case, the independent variable is going to be caffeine, and the dependent variable is going to be test performance. So my problem statement would be test performance is important for the success in the class. Okay? And so how are we going to get people to do better in a test? So my question is, does caffeine affect test performance? Hypothesis: students who drink 2 cups of coffee before the exam will perform significantly better than those students who do not drink coffee. So that is my hypothesis, and let's see how I'm going to make this happen in my method section. There are 7 introduction to psychology classes with 30 students in each at Kaiser University. I'm making this up, so I just want you to play along. This is how you're going to do your method section for your paper. You're going to make it up. This is not something that is really going to happen, because you're not really allowed to do these things. So I have 7 classes. I got 30 students in each class. That's 210 students I'm going to do this with. The midterm exam is scheduled for all students on Thursday, May 23rd of 2017. Obviously, that's in the past, at 9 a.m. for all students. So why would I do something like that? Because I'm controlling for any kind of extraneous variable, like time, like location, like even the students that I'm pulling from students who are coming from the exact same background. They're in the exact same class, so they should know how to do these things. Each of the classrooms resemble each other, and the temperature is set for 73 degrees. Once again, controlling for any kind of extraneous variables, like if their classroom is too hot, too cold, is it different, is it well lit, is it not well lit? These are all variables that can affect the dependent variable. So we try to control for everything, okay? Prior to the exam, the students are given a short questionnaire or survey where they're asked the following questions: their ID, their gender, age, how many hours did you study for this exam, and did you consume any caffeine this morning? If the answer is yes, how much caffeine, and then what kind of caffeine? Did you get in a coffee, an energy drink, energy shot? Now, why would I ask all those questions? Well, because all I want is the caffeine, right? But you ask more questions, things like gender and age, because at some point, if you do get a significant result, you might want to look at it even more so. Is there a difference between men and women, how they perform? Is there a difference between age? Is there a difference between studying? So you could actually compare studying caffeine intake and the results on the exam. Students then are given a brief description of the experiment and asked to sign to give consent to participate in the research. That's your informed consent. Ethically, all participants must consent to participate in a study. If they do not, we cannot publicly, use this information. Now, yes, we do sometimes do data analysis on results of things, but that's not for publishing because the students or the participants never gave permission for that. So the method. Students are then given the exam, right? And they're asked to put, instead of their name on the top of the exam, they're asked to place their student ID number. Why would I do that? I would do that to keep their anonymity because, once again, ethics mandates that if I'm going to use anything from the individual, it should be something anonymous. Okay, this also gives me the opportunity to remove any kind of experiment or bias that might be there. So, like, let's say these are my students and I really like a few of them. So if I see their name, maybe, that kind of thing. So student ID is put on it, so that is removed from the possibility of confounding variables as well. The data from the initial survey afterwards is inputted into the stats program that we're going to use to run the data. So the ID, the gender, the age, hours of study, and the amount of caffeine, and the type of caffeine. And then the results of the exam are entered right after it, corresponding to the student ID. Okay, there's your method. That's all the methods. So how are we going to do this? What kind of statistics can I do on this data? One of the things I can do is ANOVA, an analysis of variance, where I would look at specifically my hypothesis. I can calculate the difference in scores on the exams, that's the dependent variable, from the group of students who used caffeine prior to the exam compared to those who did not use it. And I can compare those two numbers to see if there's a significant difference in the results on the exam. And that would prove or disprove my hypothesis. I can also calculate the scores in the exam based on gender and then age. Okay, and I could do an analysis of variance like that as well. I could also do a correlational study. This would be non-experimental, right? So I could look at the relationship between the amount of caffeine ingested and age. And I could also look at the amount of caffeine ingested and test scores. So as the amount of caffeine raises, do the test scores raise? That would be, that would show a strong positive correlation. All right. Okay, I think that is it for now. Yes, it is. And if you have any questions on this, email me and I will be happy to discuss it with you. Have a good Thanksgiving. Good night.